Thank you. So today is about programming language, the programming language of printers. And if you're like me, like 2 years ago, my sole experience with PostScript was printing issues. And we can all agree that printers are very boring and hated appliances. But I got obsessed with their language. And here is what happened. So this is a demo. I didn't take my printer with me, sorry. But this is my kid, T2, playing chess with a printer. So the chess engine is being executed on the printer. That's very important to understand. And second, last but not least, we had to set a bidirectional communication channel with the printer. That was not an obvious thing. So I will take through the journey and demonstrate and show you various hacks. So first part is programming in PostScript. PostScript is an ancient language from the 80s. It was shipped by Adobe, who masters the software on the computers and licensed the PostScript interpreters for the printer. So a perfect business case, and it is still used nowadays. A PostScript interpreter is a very simple language since it has to be interpreted on the printer. So it only has 4 stacks. You put all the procedures and variables as dictionaries. They are defined as dictionaries, the name, the content, key value, an operand stack to interpret the language with operators and operands. This is what PostScript looks like. So it, you put basically, you pile up, if I may say, operators and operands, and they get executed as we go. It's a graphic-oriented language, since it's for printers, right? And how can you write PostScript on your own? So basically, nowadays, you download GoScript. It's an open-source PostScript interpreter. I had to write a PostScript mode for my favorite text editor, since obviously there is no IDE or debuggers. And interestingly, even the LLMs and AI, Cloud, GPT, they are not trained very much with PostScript code. So you are a bit alone when you are hacking PostScript. By the way, this code is drawing the Brazilian flag. It turned out that you can also execute or interpret PostScript in other environments. Some guy on the internet sent me this. He somehow compiled PostScript in WebAssembly and wrote a JS wrapper, so it works. And this is one of my secret projects. It's a Swift application linking with GoScript as a dynamic library. So it kind of works. That's why I just recorded the demo and don't play it myself. And it even works on a next step. So this is a next step to the ancestor of macOS 10 from 1995. So we can run PostScript in various places, but how powerful it is. To know that, we had to write I had to write a brainfork interpreter, and as we can interpret hello world in brainfork, then PostScript is consequently Turing complete. Okay, so we have a language, we have an environment, we can feel that there is some power there. So what can we do? Traditionally, if you print on a printer, you basically cut a PostScript program. I insist it is a program, it's not a static file such as a PDF. It's a program being interpreted on the printer. So you send it on the printer on port 9100. This is the standard way to address your printer. Now, it turns out what this very simple Unix trick, the dash here, you keep the line open. So you can get feedback for the printer and enter subsequent commands. You can even have no file at all and get a REPL on the printer. So it's very important because we shift totally the mental model from printing to executing. This was my very first experiment with an interactive game on the printer. And in the small booklet that you got, there is an article where I show that so this is a Tic-Tac-Toe program, minimized, and it is wrapped into a vector. So if you send that file to the printer, it will leave the payload on the printer. And then you simply connect to the printer and you can play. So basically, you can store programs on the printer. Okay, this was like a POC. Now, how far can we go? This is an infamous chess program for PostScript that I wrote. So the challenges were not where I expected them to be. It was more in user I/O, because PostScript is not supposed to be an interactive language. And for the rest, it's basic software engineering stuff, so modularization, unit test. In terms of data structure, you see that the board is simply a string of 64 bytes. For the design, very simple. As PostScript is a graphic-oriented language, you just draw with move to line 2 the pieces. And the game engine is a standard one, so there is a min-max algorithm that will try to optimize some value, and white have to make it high and black to make it low. So nothing really that difficult. And now the question is, if we remove the constraints of playing, of running something on the printer, what else can we do with PostScript? Sokoban, you guys know Sokoban? It's an old Japanese game appearing on early gaming consoles. You have to move, it's a brain teaser if you want, you have to move boxes on the holes. So here is a recorded demo. And note that there are two shells. Okay, I need two terminals windows to play. I will explain why. It's due to user input. The thing is, we do not want to wait to hit the enter key. In the tic-tac-toe game, okay, I hit X, enter. Now I want to play with the arrows. So how do we do that? The trick is to send, so first terminal sends a PostScript file. It gets the PostScript file with a pipe, a Unix pipe, and a second process will switch to raw mode, which means that we don't have to hit enter, and as soon as I press the arrow key, it ends up in the pipe. So that's the trick to be able to play Sokoban. Images, nothing complicated, everything described in code, there is no external asset. And even the levels are described in a standard way, so I was not aware, but there is a standard way to describe Sokoban levels. So you can very, very easily write your own levels and share them. Now, the most complicated game, or most complete game I wrote, was probably Tetris. What does this implementation feature? Real-time input, direct drop, so it's not blocking. The program is not awaiting for some keystroke to go on, not like Sokoban. It features everything that you can expect from a Tetris game, like increasing speed, random bags. There is a subtle algorithm to ensure some fairness in the pieces drop. It even stores and persists the high scores, uses the same scoring scheme as a Nintendo implementation, and this week I managed to produce some sound, hence the test before the run. So just a couple of slides to present the implementation. All the tetraminos, as they are called, are described with binary arrays. It's very, very simple. We only have to keep track of 4 integers, the current tetramino and the next one. And for each, we have the ones, is it a T, a J, a Z, and their generation, if I may, so their rotation. So what may appear complicated or intimidating turns out to be very, very, very simple. The whole game is only 600 lines of code. I will show you. In terms of data structure, again, so we have a grid, and all the tetramino are represented with their number, and I just add 10 to identify the one that is dropping, and as soon as it has hit some other tetraminos, I remove 10 in each cell. So this is a random bag algorithm. Basically, the algorithm will send you those 4 tetramino in a random order. And when they are all sent, it will start again. Because yes, PostScript has a random operator. And some people are surprised that if they print the same document twice, then you may have two different results if you use a random operator. So this was the most complicated thing to do, or complicated. When you have the answer, it's not complicated. But I spent a couple of days looking for a good solution, hacking with Unix pipes and so on. And it turns out that you can simply have the program polling, if you want, some text file where you send the keystrokes. And that's how it works. And that's how the program is not blocking, waiting on keyboard inputs. Because we don't want to, we want the pieces to keep on falling. And as a bonus, this is what I did this week. So I added to the Tetris PS production of MIDI messages. MIDI messages are then read from a third terminal, which runs a Python script with a MIDI library, and it sends the MIDI data to GarageBand. This is a demo with sound. So you see those three terminals. It's a proof of concept, huh? So wait for the line. Hey. Okay, so now, at this point, you have everything that you need to write your own games. It's totally feasible. We have no blocker, nothing that we do not know how to do to write Pac-Man or even maybe Outrun. You can even produce some kind of animations with simple tricks. You clear the screen, you draw, and you wait. You clear, you draw, you wait. And this is how we can get basic animations like this. Okay, so I've presented briefly the PostScript programming language. It's really a language interpreted on printer. We've seen what we could do on the printer, what were the difficulties to overcome. I showed what we could do on the desktop. And now we would like to show you how we can minimize that code. It's not necessarily useful, but for some reason, it's something that I am into. If I may say, it's Gambiara inside Gambiara. So look at this. This is the brainfuck interpreter that you saw right before. And I managed, but it took me a huge amount of time, but I managed to take it down to 5 lines. Same with this rotating cube. It is a pseudo 3D, and this single code is enough to produce this rotating code. And this I didn't write myself, but I want to show you because it is really mind-blowing for the mind-blowing conference. This is a ray tracer that was written in the obfuscated PostScript contest in 1993. It was a thing organized at MIT, and some student, that guy, Takashi, he wrote this very, very impressive ray tracer. At this point, I have time to show you a little demo. So I open GoScript, I paste it, and you have the ray tracing executing. And I became obsessed about this code. And I really opened everything and tried to understand precisely how it did work. And I managed to shrink down the code from 760 bytes down to 727. It may not seem a lot, but for me it means a lot because it means hours of work. And I also wanted to show you, this is the last example, that, okay, print can even play by itself. This is a puzzle. This is an old puzzle I found at my parents' place. This is an edge matching puzzle, and you have a configuration, and you have to find the solution, so the correct rotation and order for each tile. And using Takashi minimization tricks, I managed to have this very, very, very condensed code where this is in fact instructions interpreted inside the code, then interpreted by PostScript, where you define, for instance, A0, green, small red, big pink, yes, and so you understand, you define the puzzle, and you just print this, and the printer will solve the puzzle, and this is what it looks like. So you have the solution printed. It's useless, but very fun to write. And I will leave you with, I will not explain all the tricks, but maybe just one. So that pipe here, it is defined as 32 XOR. Why? Why? The answer is below. Because when you saw some character with 32, it just flips the case from lowercase to uppercase and vice versa. So you realize that the ASCII table was not created out of nowhere. There are subtle tricks in the way the characters are spread in the ASCII table. Okay, so we are mostly done. I just want to sum up. So we've seen that PostScript is a very simple programming language, Turing complete, but so it's powerful, in theory as powerful as any language, but it is very limited. There is no library, there is no network access, there is no threads. So as soon as you want to do something practical, you have to use your imagination and creativity. We've seen how to run games on printer, nothing magic except that you need this bidirectional communication channel. And we've seen how to persist the code on the printer. This is something that you can do at work. Huh? You look for, on the network, printers on port 9100. We've seen games on the desktop with Sokoban and Tetris, and how to achieve non-blocking input, which turned out to be quite simple, and even produce MIDI sound. Because on macOS, there is no MIDI synthesizer, so I had to use that Python script and GarageBand, but on Linux, I think there is a MIDI synthesizer available somewhere. You just can pipe the MIDI messages. And we've seen that the PostScript code can be minimized really, really strongly. We've seen this masterpiece with a ray tracer and various tricks to minimize programs. So, to me, this was a very nice example to present here today, because we understand that constraints and limited resources foster problem solving and creativity, because the less tools you have, the more you have to think and find new ways to do something. And in conclusion, we have twisted what is a page description language meant for 80s printers to create interactive games. There are a lot of resources on my website. Feel free to explore and to reach out later on. Thank you. Any question?
First of all, congrats. This is beyond impressive. And my question for you is, what's the next step for this? Because the first thing that came into my mind was, okay, this guy just proved that you can have a farm of printers and use that as like you can play games on my service, instead of having servers, you have printers. But is that the future? What is next?
So what's next? We were joking in the car yesterday about having a COBOL workshop or something. I would love seeing games in COBOL next year. Now, regarding the processes power of printers, for sure, we could write a Bitcoin mining farm on printers. Even it would be not efficient at all. But no, there is no next step for me at this stage. It was just about exploring and pushing the cursor as far as I could.
And that brings me to my second question, which is, what fascinated you the most? Because you just explained a bunch of fascinating things. You have a ray tracer in the printer. Like,
yeah, a very, very good question, a bit philosophical. What fascinates me the most is how complexity can emerge from very simple thing. I love, one-dimension cellular automata and how you can build everything on top of that. So PostScript is perfect for pet projects. It has altogether 400 operators. The Tetris game only uses 60 operators, no external library. So it's perfect when you have a few hours. The context you have to keep in your head is very small.
Okay, thank you. And just to snipe you a little bit, Make an OS in the printer.
Sorry?
Make an operating system in the printer.
Thank you.
Congratulations, Nicolas. It was really impressive. It was really awesome to see everything that you showed today. I was thinking because yesterday I talked with you about fax machines. And I was thinking, do they run PostScript? Because maybe then we can make multiplayer games, right?
Not that I know yet. It's true that some big corporate appliances run you never know what. They certainly have PostScript interpreters plus several other interpreters. I'm not into fax machines, but it's definitely something to investigate.
Yeah. Also, maybe it would be cool because I mean, fax machines have like kind of infinite paper, so you could have like real-time feedback other than the printer that you need to print the entire page. Maybe on fax machines you could get like a smaller output, and I mean, at least get more green because then you will use less paper, right? Thank you.
So it's more of a comment than a question, but first, congratulations on the presentation. It was really, really fun. That reminded me kind of a little of the time where we were trying to make PostScript into an application language. Like, I mean, Next had display PostScript, which you could use, but that was more of a display model than an application language by itself. But then you had Sun with News, which had a whole toolkit written in PostScript, and the intent was that you would write like the front end to your applications in PostScript, and your display server would be a PostScript interpreter and things like that. And yeah, just one comment that reminded me of this a little. I guess to make that a question, comments on whether PostScript has potential as an application language?
So yes, indeed. So in the timeline of the evolution of PostScript, there were like forks. So you mentioned next step display PostScript. PostScript was used as a display model system. It could like get callbacks for clicks and so on. So you could really use PostScript was used to display things and interact with a cursor. And it's true that Sun also implemented, it was something called News, and some guy even wrote SimCity in PostScript, so including the extensions from Sun. Nowadays, PostScript is still a thing for various reasons, legacy, but also for high-end printing. Yes, I think why it is not used that much anymore is because it was taken over by PDF, and it's a much better document. Basically, due to the internet, we had to exchange electronic documents, and you don't want to compute those documents each and every time. You want the result of the computation. If I have a huge PDF, I want to print page 300, I need a static document, a static format such as PDF, and not as PostScript. Thank you.